Hello students, welcome to Kajal of Physics classes. Okay, now we need some concept about the Newton laws of motions and equilibrium. First, in the first video, we have read Newton's second law and the equilibrium concept. Now we start with Newton second law and equilibrium concept. Equilibrium means resultant force equals to 0. You already know it. Resultant force equals to 0. So fx, fy and z 0 and tau x, tau y and tau z 0. And now for equilibrium there is a fantastic theorem that is called Lami's theorem. Lami's theorem, okay. Lami's theorems apply when the collinear forces acts on a body. Three or more collinear forces acts on a body. Suppose body A, three or more collinear forces act. That is F1, F2, F3, etc. And the angle is alpha, beta, and gamma. Then body is in equilibrium whenever the rule, sine rule, that is coming from the sine rule of the triangle, in properties of triangle in the mathematics. Just like sine rule, ABC is a triangle, you know that's if the side length A and it is B and C, then A by sine A equals to B by sine B equals to C by sine C. That is nothing but the same concept, but it is not a general triangle, it is a vector triangle. When F1, F2 and F3 are represented by the triangle, then you can apply this law. So that will be the vector triangle. That will be the vector triangle. And F1 by sine alpha equals to F2 by sine beta and F3 by sine gamma. That is the Lami's concept. Okay, you can easily apply these three sides along the three sides of a triangle, three vectors. If you take F1 is along this, then F3 makes an angle beta. So if it is beta, if F1 is here, F1, F3 makes an angle beta, so F3 and F3, this will be F3, then that will be beta, so this will be 180 minus beta. And F2 makes an angle alpha with F3, so if it is F3, then F2, this will be F2, and this will be again alpha, so this will be alpha minus 180 minus beta. And between the F1 and F2 gamma, so that is F1 and F2, and this will be gamma. So that is 180 minus alpha, 180 minus beta, and 180 minus gamma. Okay, that is, so you can just represent by any triangle. And that is F1 by sine 180 minus alpha, F2 by sine 180 minus beta, and F3 by sine 180 minus gamma. That is sine 180 minus theta is nothing but sine theta. So this formula is the concept coming from the triangle, this triangle rule. A by sine A, B by sine B, C by sine C, and only concept is that the particles should be in equilibrium because total resultant force should be 0. And that is means F1 plus F2 plus F3 should be 0. You can apply this concept in Newtonian mechanics in different kind of problems. I will give you some example 1 and 2. Then you can understand that concept very easily. Okay, I will give you some example here. 1 and 2. Some example I will give. 1 and 2 example. Okay, I will give you. So the first concept is first figure is here string. Suppose there is a body, a mass M, and there is a string, and there another string, and another body of mass M2. This is M1, and it is placed on a surface. There is the three strings here. Okay, and you can take the tension on each string T1, T2, T3. You can easily take T1, T2, and T3 because different string have different tension. We have two concepts. Different string have different tension, and same string has same tension. Okay, that's the concept. And that is T1. This is 90. Suppose this is alpha. Suppose this is alpha. Suppose this is alpha, then this should be 90 minus alpha. So you can get the three angles. This is 90, this is 90 minus alpha. So T3 by sine 180 minus alpha, that is T3 by. T1 by, that is sine 90, okay, and that is T2 by this angle. This angle is 90 plus alpha. So T3 by sine 90 plus alpha. That's your equations. T3 by sine alpha, and that is T1 by 1, and T3 by cos alpha. So that's the Lami's theorem, and you can easily find T1, T2, relations between T1, T2, T3, and for equilibrium, P3 is nothing but M2G. So you can find easily the value of T1 and easily the value of T2. That is T2 bar. This will be T2. T2, okay? T2 by sine 90 plus alpha. So you can easily find T2 equals to M2G here. Here T3 equals to M2G, okay? So T3 by sine 180 minus alpha, T1 by sine alpha, sine 90, and T2 by sine 90 plus alpha. Clear? That's the concept about the Lami's law. Okay, you can solve the different type of problems. You can easily solve different kind of problems. That's like I will give you some another example of Lami's theorem. Suppose this is a triangle. Okay, if a bead, suppose it is bead, and it is connected with a string or a rod, and another bead is here. Okay, another bead is here. Bead can move through the string or through the rod AB or AC. This is the bead number 1 and bead number 2, and they are connected by a rod. Bead means that is a that's the bead. Okay, there is a completely hollow, and you can pass a string or rod through the bead, and it can move up and down easily. That's called good bead. So M1 and M2, the two bead are connected by the rod. ABC is a triangle. Suppose this is 90 degree and it is alpha and it is beta. Or suppose it is 60 degree or it is 30 degree. Okay. So there are three forces are present. First, tension. Second, M1G. And third, normal reaction. Third, normal reaction, that is normal reaction, N1. So three forces are present. Number one, tension, M1G or N1. Okay, sometimes electrostatics point with this equilibrium, because if the beads have charge Q1 and Q2, then there must be some electrostatics force, and this should be repulsion. And so at that time, if suppose if this has some charge Q1 and Q2, suppose if it has charge Q1 and Q2, then you get another electrostatics force, and in the time that is T minus Fe. If there are four forces, then you have to consider only three forces. So at that time, you just find the resultant of the two forces, then you get a single. So number of forces here 4, but number of forces I take only 3, because N1 T minus Fe now my one of the force, and M1G is one of my force. Okay. So again you can apply the Lami's theorem if the charge is given on the bead. Okay, it is coming from the 12th concept of electrostatics. When electrostatics point in the Newtonian mechanics, then this type of problem you face. Now only you just face tension, your normal reaction and M1G. What will be the angles? I will just give you some tips about angle 60. So this will be 30. And this is 90 because it is normal reaction, so this will be 90. Is 90 tension, this is also 90. Okay, this is 60 30, this is 90 90. Okay, and that is 90. So this is the tension, this will be total, this will be total 360 degree. So that is 90 plus 90 plus 30. That means 210 degree. So this total is, if it is alpha, then this will be 360 minus 210, 150. So this will be 150 minus alpha. That's the angle, okay? So you can write the equations as n1 by sine 150 minus alpha, tension by t by sine 120 equals to m1g divided by sine 90 plus alpha. That's the Lamis theorem for the first body, n1, okay? And again for the second body, you can easily apply Lamis theorem, okay? So that's the normal reaction. This is the M2G, okay? This is M2G and this is tension. Again you can find angles. This is 30, 90, so this should be 60, and this is 90 and this is 90, okay? And now find if it is alpha, then this should be beta, and you just find this angle 90, 90, 60. That means 90 plus 90, 180 plus 240, 360 minus 240, 120. So this should be 120 minus beta. So now n2 by sine 120 minus beta. That's the first formula of Lamis. M2G divided by sine 90. That is the second force of Lamis. And the third force, tension. That is tension divided by sine 150. Then you can get this number of equations and you can solve N1T, M2G. Some data may be given, maybe alpha or beta may be given. One of the angle is given. Then you can solve it. That is the concept of Lamis in equilibrium of the Newton. I will give you two examples. Now the third concept. You can apply this Lamis theorem to any type of problem. Any type of problem. Okay. Now our third concept in equilibrium, that is third concept in equilibrium, tension, pulley concept. I will give you some example of pulley. M1, M2. This is here TT, okay, and it is M1G and M2G. That's the pulley concept. Okay, you can find acceleration easily. Resultant force by mass, okay, and tension equals to 2m1 m2 into g by m1 plus m2, okay. That's the tension. You get this formula, okay. How can you get this? Just solve this problem. M2g minus t equal to m2a. Suppose it moves downward, it moves upward, then putting the value of acceleration, you get the tension. Now if the system, they are moving up and down, okay, okay. Now the system is moving with acceleration A. Suppose system is moving with acceleration A. That means here I apply some force and move the system with acceleration A. Then tension changes. How tension changes? 2m1 m2 into g plus A by m1 plus A. In this way tension changes. Okay, if the system moves downwards with acceleration A1, A2, then again tension change 2m1 m2 into g minus A2 by m1 plus A2. In this way tension changes. Okay, so again tension changes for the, if the system is moving upward, if the system is moving downward, again tension changes. Clear? And now this is very interesting. However, this system used in the problem, this type of problem. Suppose this is a mass m1 and a pulley is here, and another pulley is here, and another mass system here, M2 and M3. And now you just get the same concept I have given you. That is the same concept I will give them. Just I will give you this concept. If the system is moving downwards with acceleration A, and the tension Tt, and this is 2T, and this is 2T. Why it is 2T? Because this pulley mass is 0. So it is 2T. Okay? Now what is the value of tension T? 2 M2 M3 2 M2 M3 into G minus A divided by M2 plus M3. Okay? Now T 2T, so that's the 2T. So 2T equals to M1. That's, you get the two equations. Easily, within a 10 seconds you get the two equations. And you can solve the problem within 1 minute. Okay? That's the technique. You can apply in different kind of problems in tension. Or suppose two beads are moving. Okay, suppose I will give you another example of tension concept. Suppose this is a frame or system. There is a bead. There is a bead. And string passes through the bead and moves here. And there is a ring. There is a ring. Very interesting case of tension. It is rod, okay? Vertical rod. And this is also rod. If mass is, suppose this mass is M1 and this mass is M2. And then this string and that's, okay? Now, it will move downwards and it will move maybe downwards or upwards. That happens, okay? If it is just too much here, suppose initially it is here, too much lower, then whenever it moves downwards, it will move upward with some accelerations A1 or with some acceleration A2. And suppose at any time, at any instant of time, suppose this angle is theta. Suppose at any time this angle is theta. And the tension in the string is Tt. Then how can you find the relations between these two accelerations? Easily, within 10 seconds, you have to find. At first, you watch what is the effective tension of M1 and what is the effective tension on M2. Just watch it. Effective tension on M1 T or this T, the component of this T. If it is theta, then this will be theta. Okay? This will be theta. If we take this situation, this is not T, then T, theta, then this will be T cos theta. So effective tension of M1 T cos theta minus T, because, okay, and another tension is here, and this is also T cos theta. Okay, so if the body moves downwards against this tension T, and that is the T cos theta, and moves downwards, so this will be work done by the tension 0, because we know the tension is internal force and work done by tension is always 0 in the system. So here you can take the total tensions T minus T cos theta, effective tension of M1, and here effective tension is T cos theta. Okay, T cos theta. So easily you can find the relations between when you just apply this theorem, because this body moves up, so T cos theta work done by the force. This body moves down, so due to this force T and T minus cos theta, T is greater than T cos theta, so work done against the tension. So T minus T cos theta into, suppose it is x1, equals to T cos theta into x2. I will just change the side because one work is positive and one work is negative. And as you know the displacement equations, This is work done by tension 0. So that is the second line. So now 1 minus cos theta into differentiate this. So V1. So that is V2 cos theta. For the third line, just you apply A1, A2 cos theta. So that's the relations you get A1 and A2. Okay? That is the tension or constant concept in Newtonian mechanics. Okay? So we will give you another different types of example. Now I give you just a simple example that is from Proto. Okay? And you get the relations between A1 and A2. Okay? And in different type of problem, you can apply this tension for work done by tension equals to any type of problem, and you can get easily the relations between acceleration. Any type of problem you can apply. Just like I will give you an example. This is the suppose here is a body and here is a body. That is the M1 and that is the M1. Suppose that is a T and that is the 2T. So what is the relations between acceleration? If it is moves downwards, then body moves upward and move. So that's the displacement. So again, work done by tension 0. That's you can apply easily. So work done by T here against by 2T by. So 2T into x1 equal to T into x2. That's 2v1 equals to v2. So 2a1 equal. That's the relations between these two as well. This is called the work done. That is a virtual work done theorem. That is called virtual work done theorem. ठीक है? Virtual work done theorem. This is called. ठीक है? थोड़ा सा इसको हम डिस्प्लेस कर रहे हैं x2. और इसका भी थोड़ा सा डिस्प्लेसमेंट हो रहा है. उसी समय जो वर्क डन लिया जाता है उसको कहते हैं वर्चुअल. We do not disturb the system, just we take slight displacement of the body. Okay, now today the class is completed, so good day.